I remember my laptop, I thought, from Arnold, I thought the video may work better, but Ken said that he thinks that still with the desktop will work better. Okay, so I'm asked to find F inverse. So first I replace F by Y, then step 2 I have to, very good, X equals 1 plus Y over Y minus 2. Well, this is a proportion. And we've done this before in chapter 1. We know how to solve a proportion. I never thought that you would have a difficulty with this. So X, Y minus 2 equals 1 plus Y. I distribute XY, I'm sorry, minus 2X equals 1 plus Y. I move Y and I move 2X. So then I factor out Y, so I have X minus 1 times Y equals 2X plus 1. So then Y equals 2X plus 1 over X minus 1, and that's our F inverse. And of course you have to write that X does not equal 1. Right? It's a proportion. We cross multiply. Good. Anything else? Please add up your points. Make sure I graded everything correctly and I did not miss anything. And I did not add up incorrectly. That will be huge embarrassment. Okay. Anything else? Anything else? Okay. So just to show you where we are. So I'm like about 2 weeks behind or so. So I have to finish chapter 3. In chapter 3, we will briefly talk about quadratic functions. We know everything about them. We will talk about polynomial functions and then rational functions, and briefly about inequalities. This is a very short section. And then we have to talk about exponential function and log functions. And this is a total of 9 sections, 2 of which are very short, 3.1 and 3.6. Okay. Any questions for me one more time? Any questions? Yes, please. I'm hoping that not more than two weeks with the test. Yes, we are down to about 13 classes. So I'm trying. Yes, Danielle?
So we'll only chapter 3 and 4 be on the next one.
Yes. So we're down to about 13 meetings. So I'm trying to finish this in about 4. So add up your points, make sure you miss anything. Okay. So so we're back to now to chapter 3. So we continue with chapter 3. Any questions? Any questions? Any questions? So in chapter 3, we will look at 2 different types of functions: polynomial and rational. These 2 functions. In chapter 4, after that, 2 other functions: exponential and logarithmic. 2 totally separate, totally different sets of functions. Okay, can anyone give us an example of a polynomial function?
X plus 3.
Right, linear, quadratic. Absolutely, perfect. Perfect answer. 3, cubic, 4, 4th degree, and so on and so forth. 5th degree, and so on and so forth. We will not talk about the linear function. That was part of a totally different course. We're done with that. So let's talk about quadratic function. I'm going to graph an example of a quadratic function, and then I would like to look at word problems that involve quadratic. So this was done a long time ago. So we're going to start with quadratic functions. The general form of a quadratic function is f of x equals ax squared plus bx plus c. Of course, where a, b, and c are real numbers. However, a cannot be 0. Can anyone explain why a cannot be 0?
Because then your first derivative would be
Exactly. If a is 0, then it's no longer quadratic. Absolutely. Completely agree. Very good. There is another form, which your book, I think, calls it standard form. I don't agree with the name. But there is another way of presenting a quadratic function. So this is method 1 and method 2, in which we have a x minus a 2 parentheses squared plus k. So this is what I call the vertex. So this is h and this is k. They call it a standard form. I call it the vertex form. And I like to start with this. So for example, f of x equals negative 2 x plus 2 squared plus 4. When you look at this, you already have the graph in your head, right? What will be the base function used here? Good. What will be the next step after you write x squared? Left 2, x plus 2 squared, left 2. Then multiply by 2. Very good. 2 times x plus 2 squared, vertical stretch by a factor of 2. The next one will be negative 2 x plus 2 squared, which will be a reflection. Very good. Reflect with respect to the x-axis. And the final step, only now you get negative 2 x plus 2 squared plus 4, which is up 4. Okay, let me repeat the steps, please. First of all, I know the base function is x squared. Using the transformations from chapter 2, we know that x plus 2 squared is a left shift of 2. Then I know that I have to deal with the 2 in front. 2 times x plus 2 squared is a vertical stretch by a factor of 2. Then the negative sign comes into play, which will reflect the graph with respect to the x-axis. And then this will move up 4. So I don't need any other theory behind it, which we will look at in a minute, however. But I know that when I graph x squared, I get this. When I graph x plus 2 squared, I get this. Of course, I'm sorry. When I wrote it, I realized, oops. So this is x plus 2 squared. Then the stretching, vertical stretching by a factor of 2. Okay. Then the next step will be a vertical stretching by a factor of 2. I'm exaggerating a little bit. So this is negative, I'm sorry, still positive, 2x plus 2 squared. Then I will have to reflect this graph with respect to the x-axis. So here's my next graph. which is negative 2x plus 2 squared. And finally, as you said, I'm moving this graph up 4. So this will be the final graph. Bless you. 1, 2, 3, 4. I don't know exactly where it crosses, but this is definitely negative 2x plus 2 squared plus 4. We know from the previous course that this point in a parabola and this point or this point or this point, they are called the vertex. Can anyone identify the vertex for us? Exactly. So that's why I call this the vertex form, because the vertex, can anyone from here, from the general form, can anyone give us the coordinates of the vertex? Very good. So that's why I think the name of this should be the vertex form, not the standard form. But it's up to you. Use any name. I'm fine. So how will I determine for this function the x and y intercepts? How do I determine the x intercepts for any function, actually? Yes. In order to find the x intercept, I have to set y equal to 0. Very good. So I set y equal to 0, and I have negative 2x plus 2 squared plus 4 equals 0. That's why we studied this in chapter 2 to make our life easier now. So can anyone give us the steps towards solving this? Subtract 4. So negative 2x plus 2 squared equals negative 4. Then, good. Divide both sides by negative 2. So I have x plus 2 squared equals 2. And I know what to do with this. Again, from chapter 1. Take the square root. How many solutions do I have to get? So then x plus 2 must equal plus or minus the square root of 2. So x equals negative 2 plus or minus the square root of 2. I have no choice but to approximate these two. So I'll grab my calculator, and I have negative 2 plus the square root of 2. And the other one with minus. Because I will not be able, if you ask me, plot the point negative 2 plus the square root of 2, comma 0, I will not really know till I look at the approximated value. So negative 0.6 roughly, and negative 3.4. So now if you want to go back to the graph and make the necessary adjustments, you will make sure that this graph crosses here at negative 0.6, negative 0.6, comma 0. So this point, negative 0.6, comma 0. And it crosses here at negative 3.4, comma 0. Because I determined them algebraically. And finally, how do I determine the y-intercept for any function? Yes, I set x equal to 0. I go back to the original function. Oh, here it is. How much is 0 plus 2? 2. 2 squared is 4 times negative 2. And negative 8 plus 4? Right. So this is 0, comma negative 4, because y is negative 4. So obviously, if I want to adjust my graph, I will make sure that I show that it crosses at 0, negative 4. I know you remember from the previous course that any parabola is a symmetric graph, and it has an axis of symmetry. And that is x equals, it's a vertical line. It passes through the vertex, and the vertex is negative 2, 4. So this must be x equals negative 2. And since this function has a maximum or a minimum, has a A maximum. What will be its maximum value? 4. Can anyone give us the range of this function? Careful, you have to start from low to high. Negative infinity to, okay, so let me put this in writing. So we know that the maximum value is 4, range negative infinity to 4, and function has a max. Now, how do I go through all these steps and present my work when I'm asked to graph a quadratic function that is not in the standard form or what I call the vertex form? So I'm on page, I'm going to pick a problem from there. On page 343, I'm going to pick 32 on 343. And we're asked, I'll tell you in a moment what we're asked to do. So the function is f of x equals 5 minus 4x minus x squared. Again, I know from the previous course that the quadratic function or any polynomial function should be presented in descending order. So I will rearrange as negative x squared minus 4x and plus 5. And I know that the leading coefficient is negative 1. If the leading coefficient is negative, the quadratic function has a maximum. If the leading coefficient is positive, the quadratic function has a minimum. So the first question I'm asking myself is, what is the shape of this graph? Because there are two possibilities: opening upward and having a minimum, or opening downward and having a maximum. Well, I identify that the leading coefficient is negative 1, so this graph will have a maximum. In step number 2, I need to find the vertex. In the vertex form, this was much easier. I only had to read it, but this time I need to calculate it. How do I calculate it? And here's the formula. The coordinates of the vertex will be negative b over 2a, comma, f of that number. So that's one of the reasons why I have to present it in descending order. So I can correctly identify a to be negative 1, b to be negative 4, and c to be 5. Because I need to use them to determine the x coordinate of the vertex. So then negative b over 2a, can anyone dictate? Negative 4 over 2 times a, which is negative 2. There are 3 negatives, and the answer will be negative. 3 negatives, the answer will be negative, and then 4 over 2 will be 2. So I already know that the x coordinate of the vertex is negative 2. How do I find the y coordinate of the vertex? Say it again. We agree? We have to plug it in. Very good. So I have a f of negative 2, which is negative 2 squared minus 4 times negative 2 and plus 5. How much is negative 2 squared? With minus in front. Perfect. How much is negative 4 times negative 2? So negative 4 and 5, I can do whatever I want. Negative 4 plus 5 is 1, and 1 plus 8 is 9. So the coordinates of the vertex are negative 2, 9. Any questions on this? Any questions? Yes, please. No more? If the parabola is? No. It doesn't have anything to do with it. If it has a minimum or a maximum and it's not given in a completed square form, in a vertex form, that's how you calculate it, regardless of whether it opens up or down. Very good question. Okay, now in step 3, I have to find the x. In step 3, X intercepts. This is very important. If they exist. How is that possible? Well, since this function has a maximum, there are 3 possibilities for a maximum. Here's one. Here's the second one. And here's the third one. How will I know which of these situations are we looking at here? Well, the parabola has a maximum when x is -2, and its maximum value is a positive number. So what will be the maximum value here? Is it a positive number, 0, or a negative number? Positive, because the vertex is above the x-axis. What about here? What will be the y-coordinate of the vertex or the maximum value of this function? Absolutely. What will be the maximum value of this function? You don't have a number, but you can tell me it will definitely be negative. So then I know which situation this is in. Is it situation 1, 2, or 3? It's in situation 1 because the y-coordinate of the vertex is positive. So it brings the graph above the x-axis. So then I know that they exist. Furthermore, not that I know that they exist, but there are 2 completely distinct solutions. There are 2 solutions here as well, but they're both the same. But there are 2 solutions because it's quadratic. And here, there are no real solutions. So if you remember from the quadratic formula, we wrote -b plus or minus. Can anyone remind me what is up down here? Very good. Me squared minus 4ac. This quantity is called discriminant. Not the square root. Just b squared minus 4ac. And generally is denoted by delta. Forget about delta. It's not important. It's easier for me to write it. So b squared minus 4ac is definitely a positive number here because I can take the square root from a positive number and I will get 2 solutions, an x1 and an x2. How much does b squared minus 4ac equal in this situation? If there is only one solution, actually 2, but they are both the same. It must be 0. So here b squared minus 4ac must equal 0. And what about here? Right, because I can take the square root from a negative number and I will not have solutions at all. The solutions are imaginary. So in this case, b squared minus 4ac is less than 0. Any questions? Okay, I have not passed item 3 yet. So how do I find the x-intercepts for our function? I have to make y equal to 0. So I go back to the function, and that was -x squared minus 4x plus 5 equals 0. What will I do first to make my life easier on this problem? Absolutely. Multiply both sides by -1. I get x squared minus plus 4x minus 5 equals 0. And I'm hoping that I can factor and get it over with. Can I factor? Very good. So I get x plus 5 and x minus 1. I have 2 options as -5 and 1. So then what will be the x-intercepts in the ordered pair format? Very good. And 1, 0. I'm done with step 3. I found the x-intercepts. So what do I have so far? I know that the shape is a maximum. I know that I found the vertex. I found the x-intercepts. Obviously, I need the y-intercept as item 4. The y-intercept will always exist. How do I get it? Very good. So when I have f of 0, 0, 0 equals 0, 0, 5. So this is 0, comma 5. And the last two are very important though, especially for word problems, the second one. So number 5 is the axis of symmetry. Can anyone give us the axis of symmetry knowing that the vertex is negative 2, comma 9? X equals negative 2 is the axis of symmetry. Since we know again that this function has a max or a min. Good. So then I say max value of this function is 9. I can already determine the range. What is the range of this function? And now I'm ready to graph it. When I graph a quadratic function, I always start with the vertex. Can anyone tell us again what the vertex is? Negative 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here, this is the point. The next step must be the axis of symmetry, which is not part of the graph. Therefore, I will just graph it as a dotted line. So this is x equals negative 2. The next step must be the x-intercepts. So I have negative 5, 0. That's 2, 3, 4, 5. Negative 5, 0, and 1, 0. Please make sure that these 2 points, the axis of symmetry and the leftmost point, x-intercept, and the axis of symmetry and the rightmost point, axis of symmetry, the rightmost point between the axis of symmetry and the rightmost point are absolutely equal, because the graph of a parabola is a symmetric graph. You cannot have 3 units here and 5 units here. Okay, and then I need the y-intercept, which is 0, comma 5, 2, 4, 5, right here. Now I'm ready to graph. Please, my graph is not going to be perfect, and I'm assuming yours is not going to be perfect either. But please make sure, or try to graph it as symmetric as possible. And do not graph the vertex like this. Okay? So in my graphs, you will notice the 2 sides are not perfect. So for example, this one is a little bit more curved than this one, but that's okay. At least I didn't graph something like this. Right? So this is the graph of f of x, negative x squared minus 4x plus 5. Now, what is more important here is what we do with these quadratic functions. Because we understand how to graph it, we will go through the shape, vertex, x-intercept, y-intercept, and the axis of symmetry and the max value. Okay? That's not such a big deal. We know this from the previous course. But what I would like to look at is at least one word problem, like 59 on page 344. A ball is thrown upward and outward from a height of 6 feet. The height of the ball, f of x. So f of x is in feet, and it's the height. So I'm copying the function now. F of x equals negative 0.8 x squared plus 2.4x and plus 6. Where x is the ball's horizontal distance in feet from where it was thrown. So one more time, x in feet, horizontal distance. I have to take notes. When I read a problem, I take notes so I remember what is given, what is required. Okay, part A. What is the maximum height of the ball, and how far from where it was thrown does this occur? So in part A, I'm asked to find the maximum height. So here's what goes through my mind. I say, okay, maximum height. Wait a minute. Let me look and see what type of function this is. Oh, I see. It's quadratic. I see that the the coefficient, the leading coefficient is negative. Okay, fine. It makes sense. I'm asked to find the maximum. And then I'm asking myself, okay, which point will give me the maximum? And the answer is the vertex, the y coordinate of the, excellent. Good. So now I'm asking myself, how do I find the vertex? Thank you. Negative b is 2.4. 2 times a, negative 1.6. Multiply both sides by 10, and of course simplify those negatives. So 24 divided by 16, I'll divide by 8. And this is 3 and this is 2, 1.5 seconds. But this is not what I was asked to determine. I was asked to determine the maximum height. So what do? So I found negative b over 2a. Exactly. I have to go back and plug it in. So f of 1.5. I'm going to use my calculator. I don't know what I did with it. Okay, here it is. So negative 0.8 multiplied by 1.5 squared and plus 2.4 times 1.5 and plus 6. And I got 7.8. Measurement unit, please. Very good. So this is the maximum height. In part B, how far does the ball travel horizontally before hitting the ground? Oh, actually, I made a mistake. It's not seconds. It's also feet. Sorry. I was thinking about time, but no, this x is in feet. So we're asked how far does the ball travel horizontally before hitting the ground? So imagine that I throw a ball, goes up to a maximum, and at some point in time it hits the ground. So here's my function. What am I asked to determine over there? Right. Very good. Okay, how do I find the x-intercept? Of course I'm going to come up with 2 because it's a parabola and it goes up to a maximum and then come down, so it has to cross twice. But then I'll figure out which one I really need. So how do I find the x-intercepts? Good. So negative 0.8 x squared plus 2.4 x plus 6 equals 0. I have to set y equals to 0.